Hello everyone, welcome back. Today we're doing chapter 10, which is the rational consumer, and I'm using Krugman, Wells and Parkinson's textbook, which is Microeconomics, 4th Canadian edition. In this particular chapter, we are looking at consumer behavior and how it is reflected in the law of demand or the demand curve. Remember, demand curve is simply giving us a relationship between price of a good and quantity demanded. This quantity demanded means that the specific amount that you're willing to purchase at a particular price is reflecting the fact that you want these units, you can afford these units, and you must have made a definite plan to buy these particular units. So when we demand something, quantity demanded over here is the amount that we're willing and able to purchase of this particular good. So it is encompassing the idea of our wants and our affordability. Consumer choice is therefore influenced by these two factors: consumption possibilities or the budget constraint. This is going to identify what consumers can afford and what they cannot afford. And secondly, the description of their likes and dislikes, which we call consumer preferences or utility. So this will take us further into the concept of utility and marginal utility. So let's try and set up our model now. So we are trying to describe our choices in the form of preferences or utility. We are going to assume the individual is a rational economic agent, so he's always trying to exploit opportunities to make himself or herself better off. When we say the word utility, we're essentially trying to measure satisfaction that we derive from the consumption of a good or service. So we are essentially able to now measure happiness or benefit that we derive from the consumption of goods and services. And the unit in which utility is measured will be called utils. Utility maximization is the goal of the consumer. Remember, you're a rational economic agent. So when you're trying to maximize utility, that's your goal. You're going to exploit opportunities to make yourself as happy as possible. Total utility is what you derive from the consumption of all of your activities. So if you're consuming 10 different things, what's the total utility from each of those things summed up? That is your total utility from the consumption bundle, which in my example was 10 different things. Marginal utility refers to the additional utility gained from consuming one additional unit of a good. So by how much does your total utility change when you consume one more unit of a good? That is your marginal utility. Let's look at an example to explain this further. Let's assume you really like egg rolls. So your preferences are such that you do not dislike them. I'm assuming that about you. And secondly, I'm assuming that you're really hungry. So if you're hungry and you like egg rolls, the first one is going to taste really awesome. So the satisfaction you derive from the first egg roll is hypothetically going to be very high. Let's assume you get 15 utils of satisfaction from the first egg roll. Second one is going to taste great, but not as much as the first one. It's not going to give you as much satisfaction as that very first one. So let's assume that's 13 utils. And then you keep on consuming more and more egg rolls, and we'll see that for each additional unit of egg roll consumed, the additional satisfaction that you're getting from each additional unit is actually declining. So this is called the law or principle of diminishing marginal utility. It's elaborating on this phenomena that we observe, that as you consume more of a good, each successive unit of a good gives you less total utility or adds less to the total utility than the previous unit. So marginal, remember, is the amount that is added to total utility because of a particular unit. So you can see marginal utility is declining as you consume more and more egg rolls. We can actually elaborate on this further with this table example. So here I have consumption of egg rolls rising from 0 all the way to 9, and marginal utility is positive, at least initially, but it is diminishing. So this is exhibiting your diminishing marginal utility over here. As you consume more and more egg rolls, each additional egg roll is giving you less than the previous unit. And eventually, if you're really full, the 9th egg roll is actually giving you negative marginal utility. So the additional satisfaction you get from the 9th egg roll is actually negative. Total utility can be calculated by using these numbers. It's simply the summation of your marginal utility up to a particular consumption point. So for example, if I'm consuming only 2 egg rolls, my total utility would be 15 plus 13, which is 28. If I'm consuming 3 egg rolls, my total utility from 3 egg rolls would be 15 plus 13 plus 11, and so on and so forth. So I can easily calculate my total utility given my marginal utility column. Vice versa, if you're given the total utility column, you can always calculate your marginal utility. So as consumption rises from 0 to 1, marginal utility is 15 because the increase in total utility is of 15 utils. As consumption rises from 1 to 2, the increase in total utility is of 13. So that's your marginal utility from the second egg roll, and so on and so forth. So if one of them is given, you can always calculate the other one. Now, what are we observing over here? We have diminishing marginal utility. So marginal utility is positive initially, but it's falling. It can be 0 and can also be negative. As long as marginal utility is positive, total utility is rising. As marginal utility becomes 0 or negative, total utility will either not change or become negative. In this case, there was really no 0 marginal utility, so we jumped from 1 to -1. So, but hypothetically, we could have a consumption over here, let's say of 8.5 egg rolls. For additional half an egg roll, it's 0. So total utility will now not change. But as you consume the second half of the 9th egg roll, it becomes negative and total utility falls. So marginal utility is typically positive, can be 0, and can also be negative. But this is typically for very high levels of consumption. Total utility is increasing as long as marginal utility is positive. It starts to decrease as marginal utility is negative. We can actually also draw our total utility curve and a marginal utility curve next. So the law of diminishing return is expressed in this negative slope of our marginal utility curve. So as you consume more egg rolls, marginal utility decreases. As you consume less egg rolls, marginal utility will increase. So as we consume more and more of a good, we get lower satisfaction, or additional satisfaction is decreasing. As we consume less of a good, it becomes more precious to us. So the additional satisfaction is now actually rising. Total utility is increasing, but at a decreasing rate. It reaches a maximum point, and after that, it starts to fall. Why is it falling? Because the additional satisfaction from the 9th egg roll was negative. Therefore, total utility for 9 egg rolls is now lower than the total utility from your 8th egg roll. Also note, how do we calculate slope of a curve? So what's slope of total utility? Slope is rise over run. In our case, change in total utility divided by change in consumption of egg rolls. So I'll just write change in Q. So this is quantity of egg rolls. So note, this is the additional utility you receive because of additional unit consumed, which is essentially the same as your marginal utility. So the law of diminishing returns is also captured in the slope of your total utility curve. It will always have a decreasing slope because of the principle of diminishing marginal utility. Now remember, a consumer choice had two main principles. One, we want to maximize our satisfaction. This is going to be measured in utility. And this satisfaction is, maximized given some constraints that we face. Remember the budget or consumption possibilities that we were talking about. So let's talk about the second part now. What's the budget that the consumer faces, or what are the consumption possibilities that the consumer face? Consumption possibilities are not unlimited. Our wants are unlimited. We always like more of everything, typically. However, we cannot afford more of everything. So why is that? Because typically consumers are working with a set amount of income. So they have limited resources. The income is limited. And also they're working with prices of goods and services, which are not determined by consumers, or at least not by the individual consumer. An individual consumer works with whatever is the price of egg, Coke, bagels, etc., whatever they're consuming. They're working with the prices of those goods and services already given to them. So these two will determine the consumption possibilities that consumer has at his or her disposal. So let's try and define those consumption possibilities. These are going to be defined through the budget line. A budget line is simply going to be this, solid downward sloping line, which is going to give you all the possible consumption possibilities for a given consumer. This budget line is essentially a boundary between what the consumer can afford and what the consumer cannot afford. So a point like A is affordable, but a point like B is not affordable. So it's a boundary between affordability and what you cannot afford. Secondly, note that any point on the budget line, a point like C, is affordable, and you're also spending all of your income. So all these points on the budget line, including these intercepts, are affordable and you're spending all of your income. In this model, we will assume that consumers are going to spend all of their income, and that's an efficient outcome because there's no future. So it's a very simplified version of reality. Consumers are not saving any income for the future or for the next time period. There's only one time period in this model. So it makes sense to spend everything that you have on the two goods that you are working with. And again, remember, simplified version of reality. So we'll be working with only two goods at a time. In this example, I have egg rolls and Coke, and we want to see what are the consumption possibilities for the consumer given his or her income and the price of the two goods. So let's construct this budget line given some tangible numbers. So I'm going to assume that the income of the consumer is $20 and the prices that he is working with are $4 and $2 respectively for egg and Coke. Now, in order to construct your budget line, the first step is to draw your two-dimensional space and measure the quantity of the two goods on each axis. So I'll put egg rolls quantity on the x-axis and quantity of Coke will be measured on the y-axis. Note, this is not your demand curve, so I don't have price of egg rolls over here. In fact, I have quantity of the two goods on the two axes. Now, next we want to see our consumption possibilities. So how do we define our consumption possibilities? Remember, our consumption possibilities are constrained by our income and the price of each good. So what's the maximum consumption of egg rolls possible given an income of $20 and price of egg roll is $4 each? So I know that if I have to pay $4 for each egg roll, the maximum amount of egg rolls that I can get is 20 divided by 4, which is 5, and that gives me my horizontal intercept. This is the maximum consumption I can have of egg rolls if I was to spend all my income on egg rolls. Likewise, what's the maximum consumption of Coke that is possible for this particular consumer? So again, income is 20 divided by the price of Coke. That will give me 20 divided by 2 is 10 Cokes. So I can have, at the maximum, 10 Cokes only given the income of 20 and the price of Coke as $2. Once I have these two maximum possibilities for each good, I can connect these two intercepts and get my budget line. This downward sloping budget line is giving me my consumption possibilities and giving me that, boundary between what's affordable and what's not affordable. Any bundle on the budget line is an affordable consumption bundle. The negative slope of the budget line is giving us the trade-off. So what's the slope over here? Slope of the budget line is simply rise over run. So our slope in this case is 10 over 5, negative 2. So what is this negative 2? It's telling me every time I want to consume one additional egg roll, I have to give up 2 Cokes. So in order to consume the first one, I must give up 2 Cokes over here. So I have another consumption bundle which is on the budget line, and it's 1 and 8. If I want to consume 2 egg rolls, I must give up another 2 Cokes. So that gives me another bundle on the budget line, which is 2 and 6. And then likewise, if I want to consume another egg roll, so I want to take the consumption of egg rolls to 3, I must give up 2 additional Cokes. So that gives me a bundle of 3 and 4. And then I have similarly 4 and 2. And lastly, if I'm consuming 5 egg rolls, I won't have any money left over for consumption of Coke. So I'll have 0 Cokes in this case. And of course, this was our one possibility also, where I'm not spending any money on egg rolls, but all the money is spent on 10 Cokes. So the budget line is giving me these consumption bundles that are on the budget line. I am spending all of my income. I cannot consume a bundle like 3 egg rolls and 6 Cokes at the same time. This is an unaffordable consumption bundle. Likewise, a bundle that is below the budget line, let's say 1 and 4, this is telling me I'm not spending all of my income. If I'm buying just 1 egg roll and 4 cokes, I'll have money left over. I can easily increase my consumption of egg rolls, or increase my consumption of coke, or I can increase my consumption of both these goods. So this is an inefficient consumption bundle in the context of this one time period model. Slope of the budget line is giving us that trade-off. So what it is telling us, for each additional egg roll, because egg roll is on my good on the x-axis, how many units of the other good am I giving up? Inverse of the slope will give you, for each additional coke, how many egg rolls do you give up? In this case, that would be 1/2. So it's telling you for each additional coke, we must give up half an egg roll. So the trade-off, remember, is exhibited in the downward slope of the budget line. Let's now look at a formal equation for our budget line. Remember, our assumption was that you're spending all of your money on these two goods and services. So total expenditure must equal your total income. So we have total expenditure on the two goods, price of egg rolls times egg rolls, plus price of cokes times the quantity of coke, must equal our income. Now remember, I'm measuring coke on the y-axis and egg rolls on the x-axis. C and E are referring to the quantity of egg rolls and quantity of coke respectively. So I want to write this as an equation where C is a function of E. So let's solve for our equation. Solving for C, or isolating C, we have C on the left hand side and everything else has been taken to the right hand side. If you wanted to do in 2 different steps, all I've done is I've kept this on the left hand side and this is I minus PE times E. And now I want to get rid of the PC, so we divide everything by PC, or price of coke. So this becomes income divided by price of coke minus price of egg rolls divided by price of coke times E. And that is our equation over here in this line. So what is income divided by price of coke? That is your vertical intercept. Remember, income and price of coke are something that is already given to us. It's not determined by the consumer. So income divided by the price of coke is giving you your vertical intercept. And price of egg roll divided by price of coke, or you can say price of the good on the x-axis divided by the price of the good on the y-axis, is giving you the slope of the budget line. So we have our vertical intercept and we have our slope. So this is our vertical intercept and that's our slope. In our case, that's price of egg rolls divided by price of coke. We just did this example with income of 20. Price of egg rolls was $4 and price of coke was $2. And let's see if we get the similar things that we got in our previous diagram. Vertical intercept should be now income divided by price of coke, which is 20 divided by 2 is 10. And that's exactly what I got on my previous slide. And what was our slope? Remember, our slope was 2. Let's see if our slope matches this equation over here. So price of egg roll divided by price of coke, which is 4/2, is again 2. Every time you consume 1 additional egg roll, you'll have to give up 2 cokes. Now, consumption possibilities are not static. They can change if income changes or the prices that we are facing, they change for either of these two goods. Let's look at the first hypothetical assumption. What happens if income changes? If income changes and price of egg rolls and coke, or price of the two goods, are not changing, this would translate into a rightward shift in your budget line. The budget line will shift outwards and it's a parallel shift. Remember, slope of the budget line is px over py. So now the slope is not changing. If income goes up, slope remains the same. So the trade-off is the same. Every time you want to consume 1 more egg roll, you're still giving up 2 cokes, but your overall consumption possibilities are higher than before. You can consume more egg rolls and more coke because your income has gone up. And of course, vice versa, if your income goes down, your budget line will see a parallel shift inwards. Your intercepts over here will be lower, but the rate or the trade-off or the exchange rate between the two goods will not change because nothing has happened to the prices of the two goods. Another alternative to change in the budget line could be when there's a change in the price of one of these two goods. So let's assume we have increase in the price of egg rolls. So if I have income is the same, it's still $20, but price of egg roll goes up. Note that because price of egg rolls has gone up, I can now afford less egg rolls. So with the $20 spent only on egg rolls, I cannot consume as many egg rolls as before because egg rolls are now more expensive. In this particular example, nothing has happened to my income and nothing has happened to the price of the other good. Price of Coke is the same. So nothing happens to my vertical intercept. So this is called the budget line rotating inwards. It's not a parallel shift. Now it's a rotation of the budget line. And in this particular case, your trade-off is now no longer the same. You have a steeper budget line because price of X went up. So the budget line is steeper with a higher magnitude of the slope. So it's still negative, but the magnitude, the number of the slope will be now bigger than before. Likewise, you can try working with lower income or price of the other good becoming expensive or cheaper. Let's look at our example where we had income was initially $20 and then we can see what happens if the income rises to $40. I'm going to keep the prices the same for now, $22 for each Coke and $4 for each egg roll. As income rises to $40, I can afford more Coke and more egg rolls, but the trade-off between the two will not change. The slope of the budget line will not be different. So if this is my initial budget line, let's say these are intercepts A and B, 10 and 5 respectively for the two goods. With higher income, I can now consume twice as many Cokes and twice as many egg rolls because my income has doubled. So 40 divided by 2 will be 20 Cokes and 40 divided by 4 will be 10 egg rolls. So you can see with higher income, your budget line sees a parallel shift outward. Alternatively, we can also change the price of Coke now. So let's assume the price of Coke rises from $2 to $4. In this particular case, I'm assuming nothing happens to my income. So I'm still working with $20 and nothing is happening to the price of the other good, which is egg rolls. So that's static at $4. So if price of egg rolls has not changed, income is the same, my horizontal intercept remains at B. But because Coke has become more expensive from 2 to 4, with income of 20, the maximum amount of Coke that I can buy is only 5 Cokes. So my vertical intercept in this case rotates inwards. And I have a more flatter curve. Why is this flatter? Because Px over Py has become smaller. Now I have to give up one egg roll in order to get one Coke and vice versa. So for each additional egg roll, I must give up one Coke instead of giving up 2 Cokes that I was giving up before with the green, solid green budget line. So try practicing different iterations for these changes in reduce income, increase the price of egg rolls, reduce the price of egg rolls, and see how your budget line rotates or shifts inwards or outwards. Now that we are comfortable with the budget line, remember our total utility. We want to maximize that total utility. So we are assuming that we are consuming 2 goods, egg rolls and Coke, and just like we had a total utility table and a marginal utility table for egg rolls, we'll have a similar information set for Coke available also. So we have to choose a consumption bundle which is on the budget line, meaning it is affordable and we're not wasting any resource, so we're spending all of our income, and it should be maximizing my satisfaction. It should be maximizing my utility. So what combination would be that maximizes my total utility while remaining affordable? So we can simply do that through 2 main options. Option 1 is the spreadsheet solution, and option 2 is choosing at the margin, or what we call marginal analysis. In the spreadsheet solution, all we have to do is find that consumption bundle which will maximize our total utility, given we are on the budget constraint or we are following our income constraint and the constraint given to us by the prices of the 2 goods. So essentially we have to be on the budget line and we have to choose the consumption bundle which is maximizing our total utility. So this is also called the table solution or the spreadsheet solution because you're working with just a little larger data set. So I have all of my consumption bundles that I listed out earlier as well on my budget line. Bundle A is where you're consuming only Coke and 0 egg rolls. And bundle F is when you're consuming only egg rolls and 0 Coke. All these other bundles, B, C, D, and E, have some combination of both goods. So for example, here I have 4 and 2, 3 and 4, 2 and 6, and I have 1 and 8. So these are consumption bundles on the budget line, and since we have to choose something that is affordable, not wasting any income, it has to be one of these bundles. Simple solution, the spreadsheet solution is calculate the total utility from each bundle. So what's the total utility for bundle A, total utility for bundle B, C, D, and so on, and whichever bundle maximize our total utility, that is your optimal consumption bundle. So in this case, this is already graphed out for you. This is our total utility function when we are consuming both goods. So starting from A, B, C, D, E, and F. Note that total utility when you're consuming both goods is not rising at a constant rate. Why not? Because as you consume more and more egg rolls, you have diminishing marginal utility for egg rolls. So there's a downward pressure on total utility because you're consuming more and more egg rolls. Each additional egg roll is giving you less utility than the last one. Likewise, as you consume more and more Coke, so you move from bundle F towards bundle A, again it's not rising at a constant rate because now diminishing returns for Coke set in. As you consume more and more Coke, there's downward pressure on total utility for each consumption bundle because of higher consumption levels of Coke. Because each additional unit of Coke consumed gives you less utility than the previous unit of Coke. So anyways, here we have charted out the total utility for each consumption bundle, and you can see bundle C is our optimal consumption bundle. Bundle C is the one where we have consumption of 2 egg rolls and 6 Cokes, and this is our optimal. So this is our utility maximizing consumption bundle given our budget constraint or given our consumption possibilities. Here I have a table to help you answer this question, let's say if it was in an exam. So the first thing to do is chart out your consumption bundles. My bundle A was where I have 0 egg rolls and 10 Cokes, then 1 egg roll and 8 Cokes, and then so on and so forth. Given your information for utility of egg rolls and utility coming from Coke, you can now calculate the total utility for each consumption bundle. So when I'm consuming 0 egg rolls, the total utility is only coming from Cokes, which is 56.7. Likewise, for any given consumption bundle, look at the total quantity consumed of each good, look at the corresponding total utility from that consumption for each of these goods, sum them up, and you'll get your total utility for the consumption bundle. So this is utility from each of these goods, and the last column is total utility for your consumption bundle. The consumption bundle which is maximizing our total utility is the one which is bundle C, where the combination is 2 egg rolls and 6 Cokes. So that's our utility maximizing choice. Another way to solve this problem is choosing at the margin or our marginal analysis. Now, when we apply the marginal analysis, we can think of this in terms of how much should I spend, or should I spend an additional dollar on the consumption of a particular good or not. So when are we spending, whether it's worthwhile to spend an additional dollar? When we look at it this way, it becomes a how much problem. Should I spend more? Should I spend less? How much do I consume of Coke? And how much do I consume of egg rolls? So in this case, we are focusing on a dollar spent more. Is it worthwhile or not? So how will we quantify that? We'll have to now focus on marginal utility per dollar. We have to compare the additional utility per dollar spent on each of these two goods. So if I'm getting more satisfaction from a dollar spent on egg rolls compared to a dollar spent on Coke, I should be spending more money on egg rolls. But if I'm getting more additional satisfaction from a dollar spent on Coke compared to additional satisfaction coming from a dollar spent on egg rolls, then I should be buying more Coke. Okay, so what we have to do is we have to compare marginal utility per dollar. It seems tricky, but it's quite straightforward. So now our consumer equilibrium would be where when we're spending all of our income, so all available income, $20 for example, should be spent completely, but in a way that it's equating your marginal utility per dollar spent on each of these goods. So marginal utility per dollar is calculated by simply looking at the marginal utility of the good divided by the price of that good. So marginal utility per dollar from egg rolls is MUE over PE, and marginal utility per dollar for Coke would be marginal utility of Coke divided by price of Coke. When these two are equal, we are at consumer equilibrium, or this will correspond to your utility maximizing consumption bundle. In our case, this should again come out to be bundle C. If they are not equal, it indicates to you how should you change your spending. Should you spend more on egg rolls or should you spend more on Coke? This is called your rational spending rule. When you're spending all available income such that marginal utility per dollar is equal. So let's try this rule on our example for the budget line of $20 and prices of the two goods given to us as 4 and 2. And we've already laid out our bundles, so we can compare what happens in that case when we are at a disequilibrium, or where marginal utility per dollar is not the same. What does the rule tell us to do? So let's assume we are at bundle B on our budget line. Bundle B, remember, was one where you're consuming 1 egg roll and 8 Cokes. And for your reminder, I've reimposed or copy pasted our diagram again over here. So this is our bundle B. We're consuming 1 egg roll and 8 Cokes. I want to compare the marginal utility per dollar at this bundle. So what I have to do is I have to look at the marginal utility from the last egg roll consumed. In this case, that's the first one. And my marginal utility for the first egg roll is 15 divided by the price of egg roll, which is 4, which gives me 3.75. Compare this marginal utility per dollar for egg roll on bundle B with the marginal utility per dollar for Coke. So on bundle B, I'm consuming 8 Cokes. So what's the marginal utility for the 8th Coke? Marginal utility for the 8th Coke is approximately 3.1. Why 3.1? Because in this case, we were jumping in increments of 2. So from 0 to 2, 4, 6, 8, and 10. So we had increments of 2 units of Coke each. And our total utility table was also giving us, total utility was rising from 2 to 4 Cokes, then 6 Cokes, 8 Cokes, and therefore, and so on and so forth. So once you're looking at the marginal utility for the 8th Coke, this is a jump from 6 to 8. So that was an additional total utility of 6.2. But since it's a jump of 2 units, I divided by 2. That will give me the approximate marginal utility for the 8th bottle of Coke. And I want to calculate marginal utility per dollar. So I must divide this by 2. So which is now only 1.55. So since 1.55 is my additional satisfaction from $1 spent on Coke, and 3.75 is my additional satisfaction from $1 spent on egg rolls. So as a rational consumer, I'm getting more satisfaction from $1 spent on egg rolls. So I should be spending more on egg rolls. And therefore, I will move away from bundle B towards bundle C. I will increase my consumption of egg rolls and reduce my consumption of Coke. And as we do that, note what happens. As we are spending more money on egg rolls and less money on Coke, there's something happening to this inequality over here. As you consume more of a good, its marginal utility goes down. And as you consume less of a good, this marginal utility will actually go up. Nothing happens to the denominators. Prices are given, they're stuck at $4 and $2 respectively. But what's happening to the ratio? As you consume more egg rolls and as you consume less Coke, the difference between the per dollar marginal utility is actually becoming smaller. And you will keep on spending more till both are again equal. At equality, there is no incentive for you to spend more money on egg rolls. Neither there is any incentive for you to spend less money on Coke. So once we have reached that equality, no incentive to change your behavior. As long as there is an inequality, you will keep on changing your behavior. In this case, you're consuming more Coke consuming more egg rolls and less Coke. On the other hand, we can also try a bundle like E. So let's start from the other side of the spectrum. A bundle like E is over here. At bundle E, I am consuming 4 egg rolls and 2 Cokes. And similarly, I can now calculate the marginal utility per dollar for an egg roll. So from the 4th egg roll, my marginal utility is 3 divided by the price of egg roll, which is 4. Marginal utility from the Coke, with the second Coke to be particular, would be 7.7 utils divided by the price of Coke. And in this case, our right hand side is bigger, or the per dollar satisfaction from Coke is higher than the per dollar satisfaction from egg rolls. So now I should be spending more on Coke. My consumption of Coke should go up. So if you're in a bundle like E, a rational consumer now will spend more on Coke and less on egg rolls. So you're moving towards a bundle like D. Here eventually you'll again see a higher per dollar marginal utility from Coke, and you'll keep on moving till you reach your bundle C, which is your utility maximizing bundle. At bundle C, per dollar marginal utility is exactly equal or approximately almost the same. So there's no incentive for you to change your behavior or change your spending pattern now. This is your utility maximizing bundle. Here I have the detailed format, the way you should be following it for comparing the marginal utility per dollar rule and to find your utility maximizing bundle. The trick of the game is always, first of all, find your bundles on the budget line. So given our income of 20 and the prices of the two goods, these are our bundles on the budget line. I have bundle A, B, C, D, E, F, where I have rising consumption of egg rolls and falling consumption of Coke. For each of these bundles, I can now calculate the marginal utility per dollar for egg roll and the marginal utility per dollar for Coke. So for bundle B example, we are comparing 3.75 to 1.55. Since this is higher than this one, it's telling us move towards higher consumption of egg rolls from B to C. So we are moving in this direction to 2 egg rolls and then 6 Cokes. At 2 and 6 combination, they are equal to each other with this minute difference, but this is the best we can get in this particular question. So they are almost equal. If you look at any other bundle, let's say bundle D, E, or F, you will see that the marginal utility per dollar is not the same. We have already done E before. So here we have per dollar marginal utility of 3 over 4 or 0.75, should be 0.75, or versus 5.35, which is my marginal utility per dollar from Coke. So here this is indicating to you that you should be consuming more Coke. As you consume more Coke, you're moving actually from E to D, higher consumption of Coke, from 2 to 4 bottles of Coke. And here again, it's not equal. So we will keep on moving towards bundle C. At bundle C, you can see per dollar marginal utility is the same, and we have found our utility maximizing bundle. Let's look at another example to understand our marginal utility per dollar or the rational spending rule. In this example, I have 2 goods, gum and ice cream, and prices of the 2 goods are given to us as 25 cents and $1 for each of them. We don't know what the current consumption is of each of these goods, but we do know that the marginal utility from the last gum consumed is 1 utils, and the marginal utility from the last ice cream scoop consumed is 2 utils. Note, the actual consumption of each of these goods is not given. We are just given the marginal utility from the current consumption bundle, and we are also given the prices of the 2 goods. Given this information, what do you think the consumer can do to increase his or her total utility? Next, we just compare the marginal utility per dollar from each of these 2 goods with each other and see how should the consumer spend his money. Should he spend more on gum or should he spend more on ice cream? So per dollar marginal utility from gum would be 1 over 0.25. Per dollar marginal utility from ice cream would be 2 over 1, which is 1 over divided by 0.25 is 4 versus 2. So 4 is definitely bigger than 2. So this is telling me that the per dollar satisfaction from the consumption of gum right now is a lot higher compared to the per dollar satisfaction derived from ice cream. Consumer in this case should definitely spend more money on gum. So you should be spending more money on gum and less money on ice cream. Because remember, you're a rational consumer, you're spending all of your income and you're on the budget line. So as you spend more money on one good, you necessarily reduce the spending on the other good. So the rational spending rule immediately tells us how should we change our behavior in order to increase our total utility. So in this case, we know we could go to a utility maximizing bundle by simply spending more money on gum and less money on ice cream.